Welcome to the second part of the introductory practical for the FSL course. This one's going to be about brain extraction. Now, as you'll have heard in the lecture, brain extraction is a really useful part of the start of the processing chain in order to get rid of the non-brain material so that the analysis can concentrate on what's in the brain. We're going to start by going back to our course data in the intro in our terminal. And we're going to open the GUI version for the brain extraction tool, which is the tool is called BET for brain extraction tool, and we do that on a Mac by typing this. So it's BET with a capital B, then underscore GUI, which is only necessary on a Mac. So if you're not on a Mac, you don't need the underscore GUI part. If I then press return, then I get this GUI popping up. And I can then select my input image. So by clicking on this file,
going to select the structural image called structural.nii.gz as the input image, and then as you can see as the output image, it already gives you a default of adding underscore brain to the end of the input image. And it's useful to keep that the same because that's what FSL actually assumes in some of the later processing steps.
You can choose whatever you like, and you can rename them afterwards, but this is a useful place to start. So if I want to run brain extraction now, all I need to actually do is press go. So if I press that go, you can see that it stays depressed, and in my terminal it's actually run it, and then it's told me that it's finished. So I can find out from the terminal that that's finished. I can then press exit, get rid of the GUI, and now the output is within this directory. So if I list the contents of those files, then my output is actually here. It's actually called structural brain. There's in amongst all of the other outputs. If I'd wanted to see which is the most recent output, I could actually use another option to ls, which is minus LRT. That's a long listing reversed time ordered. But minus LRT is a useful one to remember, because if I do that, then I actually get a list. So it's a long listing, it gives me lots of information. But the useful thing is that it shows you what times things were created, and that the most recent one is at the bottom of the list. So you can actually see now what's been created. So right now, which is when we've actually run this command.
Okay, so now that BET is finished, we're going to have a look at the results. So we're going to open Fossilize, and then what we're going to do is load both the original structural image and also adding the betted image, so the result from our analysis.
And I can select more than one image from the image list to open, so I'll open both of those like that. And they've appeared in this order. So I can actually change that order because that's actually most useful, and I can turn the different ones on and off. So if I've turned both of them off, now you can see if I just turn the structural on, that's what the original image looked like with all of the non-brain material on it. If I turn just the brain on, then I can see that. And so that's a useful way of seeing that things are working. If I have both on, I can't actually see the difference if I turn the brain one on or off, because actually it's identical, the parts that are inside the brain, to what we had before, and outside we're seeing through to the image underneath, which is structural. But one thing that I can do is I can change the color map. So if I change the color map of the brain to that, then I can look at that and I can actually make it more partly transparent, and then I can have a look to see whether that is a good brain extraction. And so I can concentrate on, some bits at the top. It's a little bit dark, so let's actually change the brightness and the contrast of, you notice that I'm changing it of the underlying image, the structural image now. That's a little bit too far in the contrast. There we are. So now it's a bit easier to see. Has it extracted the brain material that I wanted? Yes, pretty well. It's also extracted some non-brain material, and there are some slight imperfections in certain places. If I look very carefully, I'd be able to find, maybe a tiny little bit of brain which has been missed out here. If we're doing it for purposes like registration, that's not going to matter. And so generally, the brain extraction is very good. And as we said in the lecture, it's not meant to be perfect. It's not meant to get into the details of the folds. That's what cortical surface modelling is, which is a much more complicated task. The main purpose of brain extraction is just to separate the non-brain material from the brain material. So for things like running registration, this is a good brain extraction result. Okay, so now we've checked that brain extraction, let's do another one. So going back to the terminal now, so I'm in the same place that I was before, and I'm going to open the Bet GUI again. So I'm going to do it with an ampersand this time so that I've got the terminal as well. And some of the things that we didn't talk about before were things like this fractional intensity threshold, this 0.5 value that we just left at the default. It did a good job in this case, but you can find that there are times when the image isn't so suited to Bet to start with, and you need to alter this in order to either make the outline a little bit bigger or a little bit smaller, and so by changing this value you can do that. There are also advanced options in here which give you a range of other outputs that we could have. So one of the useful ones is a mask image, which you could select by just doing that. Now I'm not going to run things from the GUI again, I'm actually going to run them now from the command line, and this is a different option that we've got for most of the tools in FSL. So the GUI started with a capital B, but the command line version is just all lowercase, and there's no underscore GUI, of course. If I type that and just press return, I get a long list of all the different options that I've got to run it, but actually the usage, which is right at the top, gives us an idea of how is the easiest way to run it. When you look at these usages, you'll see that they're written in a certain notation which is used a lot in the Unix and Linux world. And that's when you've got these angle brackets around something, that means that you have to come up with something to replace that whole term by, and that's compulsory. You have to have something there. So in this case, you have to have the name of an input file. Similarly, you have to have the name of an output file. Things in square brackets are optional, and all of the different things down here can be put in the options. So the simplest possible way to run things would just be to have Bet, and then I would type structural, and then I would type structural brain as my output. So that's one option. We'll call it structural brain 2 now, just to differentiate it from what we did before. We're also going to use the options. So the two most common options are the -F option here, which is this fractional intensity threshold. Same thing we saw in a GUI in a minute ago. And there's also the -M option for generating a brain mask. And so we'll use both of those here. So we'll use -F, and we'll give it a value of 0.2, and we'll also add the -M. And so that's going to run another brain extraction with a different fractional intensity threshold and also create a mask image in addition. If I just run that, I press return, wait a little bit, it's already done. If I do my ls-lrt to see what are the new files which I've just created, then I can see down here I've got structural brain 2 mask and structural brain 2. So let's have a look at those in Fossilize.
Okay, so we're going to add both of those images by pressing the plus button and selecting these two images.
Okay, so let's turn both of those off to start with. So now I'm just viewing the structural on its own. Let's make that a little bit bigger so we can see all of them. Okay, if I turn that one off, I can look at each one individually. So this was the old version that we had, structural brain. It's still partly transparent, and I've changed it to red to yellow, so I could restore that to what it was. Here is the new one called structural brain 2. And here is the structural brain mask. As you can see, this doesn't have any features inside. It's either 1s or it's 0, and that's a very common thing that you'll find in lots of analysis tools. A binary mask which is useful for lots of different purposes, so we have that. And in fact, you can check how good the brain extraction was by looking at that as well. Doing the same thing that we did before. If I make that coloured and I make that slightly transparent, then that's, again, another good way of checking how good that brain extraction was. So I could either do that with the brain mask, or I could do it with the actual brain image itself. So here again I could change it to be coloured, make it slightly transparent and see what it looks like. Now let's compare this version to the one we did before. So I'm going to turn structural brain on now underneath. So my structural brain 2 is partly transparent. My structural brain is also coloured, so this is very difficult to tell because it's showing both of them at the same time. So let's see it in a different colour. So now what you see is you see things which are green are part of structural brain, the original one that we ran, and ones which are just in the red are part of structural brain 2. So if I turn that off, you just see that. It's partly transparent so we can see through. If I made it fully opaque, then I wouldn't see any of the green underneath. Alternatively, I could put it underneath the structural brain and we could see the green on top. And I could make that one transparent if I wanted to, or not. In this case, because the one underneath, the structural brain 2, is bigger, this is quite a useful way of actually looking at it. And you can see here that by putting the -f down to 0.2, this fractional intensity threshold, that actually now we've got a much bigger mask, or maybe not much bigger, a little bit bigger, which in this instance we probably don't need. I would say that actually the structural brain that we had to start with was probably the better option. But as we pointed out, there was a tiny little bit of things which had been taken away, so this is a little bit more conservative. And depending on what you want, that might be better, but it's included some things now down at the bottom which are not strictly brain tissue.
If you want, you can also have a play around with different intensity thresholds. So for example, you can increase it to 0.8 and see what that difference would make.
Okay, so that's all we're going to talk about for brain extraction. And this will be one of the things that you'll run in the very first practical of the FSL course, so it's good to have just the minimum familiarity with how you would actually go about running this and looking at the outputs. In the next part, we're going to be covering a number of other command line utilities which are collectively called FSL utils, and can be very useful at doing a whole range of different tasks in the imaging. It's good to be familiar with some of these tools. So that will be in the next video.